Awesome. Yeah. Thank you, Chris, for that introduction. I expect to be cornered in the tutoring room off to the side. As said, I'm Michael DeSa. I'm the engineering manager for the product formerly known as Chronograph, maybe Chronograph 2 or the UI. So the agenda for this talk is to just describe what time series data is at a very high level and kind of some use cases, common best practices. I'll explain a little bit the history of InfluxDB to InfluxData, talk a little bit about 2.0 and some of the things that we've been working on. I'll go into some depth about the InfluxDB data model and maybe how things have changed from 1.x to 2.x, with kind of giving you the ability to differentiate between the two. And at the very end, I'll close with some, how do I reason about schema decisions when I'm designing or kind of making my schema. Cool. So we're going to start with what is time series data. And kind of the most canonical thing whenever I think of time series data is just this kind of like ticker chalk for a stock, right? Where we're viewing some value over a time range. So common example that pretty much everybody is aware of that you can tell to anyone you come to on the street is ticker data, stock data. But it also includes things like DevOps monitoring data and things like that. It can be a single value and not just kind of some range over time. Something that people commonly don't really think of as time series, but really is a time series, is kind of logs, right? It's kind of a canonical example where just everything is coming out that has a timestamp and some data associated with it. And then finally, we have things like IoT and sensor data, where we're maybe looking at like temperature over time, things like that. Within time series, there's two major categories. There is regular time series, so that's time series that comes in at a fixed regular event. And then there is irregular time series, where you don't necessarily know when the event's going to be coming in, just that the event will be coming in. One thing to keep in mind, or kind of another phrase for this, is metrics and events. You can always induce a regular time series from an irregular time series by just doing some kind of aggregate on a regular fixed window. So great example of something that is not time series data, right? Where we're looking at, say, the temperature versus cost in some ratio. This is not time series data. However, if we start to look at things that are a little bit more fun, like maybe the viral spread of Ed Sheeran's Sing, if anybody remembers this from a long, long time ago, this is definitely a time series where we see kind of over time this kind of expansion of the popularity of a song. So the common question that I kind of always get, well, is like, what is a time series database? And my answer is it's a database where you manage and store and manage time series data, but like that doesn't really tell you anything. When I think of a time series database, I really think there's kind of two things that it should do for you efficiently, and that is range-based queries for time and able to enforce kind of data retention. So one kind of very common thing about time series data is that as it ages, it becomes less and less useful. And a time series database should really handle that process gracefully. There's a bunch of different time series databases that are out there, but I would suggest that you use a time series database. You don't necessarily have to use us. I would recommend us, but I would recommend if you do have a time series problem that you should use a time series database. Another question that I kind of get very regularly is, well, why can't I just use like Mongo or like Elasticsearch or Postgres, things like this? And you really could, but the bigger thing here is that time series is not really just a database problem. There's a suite of other things that really come along with when you have a time series. You really want the ability to visualize that time series efficiently. You want to be able to monitor and take actions and alert on that time series. And you want to be able to kind of process and do ETL on that. And it's very difficult to take kind of a suite of other products that are kind of loosely coupled together and get something that's really effective from that. So what is InfluxData and InfluxDB? So when InfluxDB first kind of came about, it actually wasn't InfluxDB. It was a product called Airplane, which was kind of an APM product. And pretty early on, our founder realized that this was, there was a common pattern that he was attacking, which was this time series database problem. And kind of around there is when InfluxDB was born. And around 2015, we kind of transitioned to not just being this database, but starting to build really a suite of other products around the tool. And we kind of started with this idea of making like a platform for time series rather than just a database. And more recently, we kind of started on this 2.0 venture where we were taking what was 4 kind of loosely coupled products and really bringing them together as one single unified thing that was focused on ease of use. So InfluxData, why InfluxDB? I think something that has held true to us kind of from the very beginning is that we are very easy to get started with, and we believe that having a vertically integrated platform for time series is the way that you do this. We aim to solve the entire time series problem as much as we can, and we want to be performant kind of across all different sizes and scales. So we want to work for people who are on really small, 1,000 series, as well as getting into the billions and billions of series. So we'll move on to the InfluxDB data model. And to explain the data model, I usually start with a typical time series graph. And for all intents and purposes, I think stock data works very well for that. Up at the very top of that graph, we have the label of the graph. We call this label the measurement in InfluxDB. It's kind of like a high-level grouping for all of the data that comes beneath it. Below that, we have kind of tags, which are things in the legend, right? They're like things that tell you what you're kind of looking at. We think of this as indexed metadata. So there are key value pairs that correspond to a particular piece of metadata. Then we have y-axis values. Those are called fields, where we can kind of get a sequence over time. And then we have time, which is in the x-axis. So the next piece that kind of becomes a little bit difficult to explain is, well, what is a series? A series is the unique combination of measurement and tags. So an easy way to think of that is if you kind of visualize all points on that blue line or all points on that yellow line or green line. So stated kind of explicitly again, we have the measurement up top, which is the high-level grouping. We have tags, which are indexed key value pairs. We have fields, which are sequenced key value pairs. Time, and then a series is kind of the unique combination of those things. So how do we express this data? We use what is called the line protocol, which is kind of a custom format. It looks like a lot like a kind of modified CSV file. So it starts with the measurement, which comes up front, CPU in this case. Then we have tags, which are those indexed values. So CPU, comma, tags. And then we have fields, which are the actual kind of sequenced data, and time. One thing I wanted to call attention to here is that there's actually two series that are expressed in this line protocol here. So we have the initial series key, which is the measurement and tags, and then we have the field idle and the field system. You really want to think about these values as separate series. They are really kind of distinct lines on that graph. Hopefully the contrast on this is okay. Cool. So where is this time series data stored, like in the system? How do I think about the system at a little bit higher level? In 1.x, the data hierarchy was we had a concept called a database, and a database was kind of really a container for like access control. So you could specify who and who did not have access to a particular set of data. And then inside of databases, we had a concept called a retention policy, which was really where the time series data lived. And inside that time series, the retention policy, it had rules and retention rules for like which series would exist and for how long. We end up kind of with this little visualization here where, up at the very top, we have an InfluxDB instance. Beneath that, we have multiple databases. Beneath that, we have multiple retention policies. And beneath that, series. And this is very confusing. I've explained this concept maybe like, a few hundred times, and every time it just never kind of follows through. Especially, the hard thing is that the database is actually not the container for time series data. The retention policy is. And it's a very non-intuitive thing. And when you query the data, it's not necessarily clear that that is the case. And that's something that we had kind of experienced a lot and decided we want to make a change in 2.x. So when we did that, we decided to kind of abandon this idea of calling it a database and move to something called a bucket. And we didn't want to have kind of this crossover with how the legacy kind of understanding of a database. We really wanted to have a new concept. And what we did is we folded all of the things that belonged between databases and retention policies into a single thing called a bucket. So buckets are containers for access control. They define retention rules for time series data, and they actually contain the time series data themselves. And just to give you a little diagram, you got a bucket and then series that kind of point beneath it. Now when we start to think about an entire 2.0 instance, maybe from a higher level, we added one level kind of abstraction on top of it, and we introduced this concept called organizations. And organizations are just logical groupings of resources. So that's like buckets, dashboards, tasks, and things like this. And then you have buckets beneath them. So a 2.0 instance really looks like this. You have the instance up at the top. Beneath that, you have multiple organizations. Beneath that, you have multiple buckets, and then the buckets contain the actual time series data. And there's a bunch of other things that are here as well. So for querying data in InfluxData or InfluxDB, there's really 3 different kind of ways you can go about it. The historical way was to use InfluxQL, which was our SQL-like query language. And then we had TickScript, which was for kind of processing and alerting on time series. And then finally, we have our next generation functional data scripting language, which is Flux. So InfluxQL was just like an SQL-like query language where you would say something like select index, comma, ID from H2 equality, where time is greater than now, -1 week, group by location. Just to give you maybe a little bit slightly different view of this, really what you're trying to say is select some fields from some measurement where some condition, group by, some tag values. This query language had a lot of limitations, namely that the only thing that could ever show up in that group by was a tag. And that meant that if you made the wrong schema decision early on, or you couldn't really get the types of data or the types of information out of the data that you had. Additionally, if you just wanted to see which tags existed for a particular time series, that wouldn't be possible at all. You had to actually specify one field in the body of the select query. So that was one problem. Another issue that we kind of had with InfluxQL is when you started to get very large queries where you wanted to do, say, cross-measurement computations, or you had like a sequence of things that you wanted to do, you ended up with these very deeply nested subqueries that were very difficult to reason about. And you kind of have to like work backwards. You would start with your base query nested inside a subquery, and you had this iterative process that resulted in a query that, when you came back to it a month later, was more or less unreadable. And so that was something that we wanted to keep in mind as we were thinking about new query languages. What came after InfluxQL was TickScript, which is the language that's predominantly used in Capacitor, and it solved a lot of the kind of readability problems of InfluxQL. It was a little bit easier to come back to it and reason about what had been going on. But the feedback that we got from TickScript was that there's a lot of internal logic that was kind of hard to reason about without having to do it a bunch of times. In addition, it wasn't really possible to take a TickScript and execute it against some data. You really had to start a TickScript, start a task, stream data to it, and just see what came out. And that made the feedback loop for learning TickScript and for becoming familiar with it very slow. And finally, we kind of took a lot of those concepts and kind of manifested them into Flux, which is our kind of like data scripting stream programming language called Flux. And the big thing here for Flux is we wanted to make sure that things were composable. So we wanted users to be able to take pieces from different scripts and combine them into something that they could use to solve their own problems. We wanted to make sure that it was extensible, both internally, meaning I could write new functionality into Flux without having to recompile the binary or write some code. I could just write Flux code and get new functionality. In addition, we want it to be shareable. We wanted users to be able to package up their own kind of logic and create libraries that they could share with others. So if I become the best in the world at monitoring CPUs, I can share that package with somebody. And finally, we wanted it to be flexible. So both TickScript and InfluxQL really couldn't operate with any other systems. We were kind of locked into the InfluxData ecosystem. And more it's become apparent that there's other types of data that you want to enrich with your time series data. And we wanted a way that we could do that. And we've built all of those things into Flux. All right, so now we're going to be moving on to schema design, or what I like to call what not to do. Over time, I used to have maybe 20 or 30 things that were in this part of the slide deck, and we've kind of solved a lot of them, which is really exciting. That being said, there are still some things that can drastically impact the performance of your queries. So one thing that you should really avoid doing is encoding data into measurement and send tags. So this came a lot back in the days when we would see graphite users, where you would end up with just this really long single measurement name that contained all of the data that can be separated down into different chunks. So you'd have something like cpu.server5.uswest with a field of value 2, right? Which is, it encapsulates all the information, but in Influx, we can separate things out to get a lot more flexibility from our query language. So it's much better to do something along the lines of having a measurement called CPU and then 2 tags, host and region, where those values are separated across. Still to this day, I see people doing this where they start to encode a bunch of information that really should be separate. The next thing that people still do fairly frequently is they use tags with very high cardinality. We've tuned the database so that we can deal with high cardinality workloads for things like container ID that might be ephemeral, that change slowly over time. But if you have something like a request ID that is changing constantly, like every single request, you're going to drastically increase the amount of cardinality you have in the database. And you might be asking, why does having a high amount of cardinality matter? The reason is, internally in the query engine, what happens is we spin up an iterator that goes across every single series, and that's just a lot of computational overhead. So you may have a very simple looking query that you end up having be very, very unperformant had you not had this be something that was in the tag set. The next piece of information is you definitely want to make sure that you don't use too few tags. So unlike a lot of systems, we're not quite an event-based system in that if you have the same series key, so same measurement and tag set, and the same timestamp, the data will be overwritten. And so you want to make sure that your data is sufficiently differentiated. So in the example I have up top, you can see that there's just a single measurement called CPU with a single tag called region, and host was a field. And you'll note that the timestamps on the last 2 points that are there are the exact same. If I were to write them in sequence, the only value that would end up being stored in the database would be the last value. And so you want to be very cognizant of making sure that you include enough series, so like enough information so that nothing collides. And this is something that I've seen people make a mistake in the past. So then the question that I get invariably after that is like, okay, well, I got what I shouldn't do, but like, what should I do? And it's really a difficult question to answer without kind of getting way into it. But the process that I would go through whenever I was doing ProServe, or if somebody ever comes up to me and how should I design my schema, would be you want to think about how you want to query your data before you get started in designing this. A lot of people will just kind of throw a bunch of data at the instance and then be like, why are things not performing? And they didn't put a lot of thought into, what do I actually need to see? Like, what's going to be running on a dashboard that's refreshing every 5 seconds versus what's going to be alerting maybe on an hourly basis? Or, I'm going to run this type of query once a month, and so it's okay if it takes a little bit longer to run than something that's maybe on a dashboard. So these are things that you want to definitely think about when you're designing a schema. So whenever I do ProServe, this is the first thing that I go through, is we do a scan through all of their databases and all of their dashboards and see what are the queries that are very important to you. And if you don't think about these things first, you can very easily end up in a situation where you have dashboards that as they load, they kind of sit there and kind of spin indefinitely, right? And it feels like, well, why is it not doing this? It's just something you need to be cognizant of. So I think one thing that could be useful is to start with maybe a schema example. And so let's say that I operate a SaaS application where there's 1,000 different services, and I want to know the request and error rates for each one of those services, and I want to be able to trigger an alert if the error rate is beyond a specific threshold for a specific threshold service. And it might be the case that different services have different thresholds that they want to be. So like, the API server can have a error request rate of 2%, where the query server can only have one of like 5%, something like that. And maybe I want to do something like I want to see the request rates for each service of the services that have the top 5 error rates, so things like that. And let's say I have this type of data available. I have the application or the service that is running, the container ID, the path, the HTTP request path, the method, the source of the client, the server being contacted, the status of the code, of the associated with the request ID, the duration, the bytes transmitted, and bytes received. So the question is, like, why would it be a really bad idea to make something like request ID a tag? Covered this explicitly. Request ID has an insanely large cardinality, right? So, say I'm handling 1,000 requests a second. This is going to blow up my cardinality to a point where when I go to issue a query and I have to create an iterator for each one of these series, things are really going to grind to a halt. The next question after that is like, okay, if request ID isn't going to be in the series, or what does my schema really look like? And duplicate slide. I would say that you should probably go with something where you maybe have a top-level measurement like latency, and then you have the tags for app, container ID, path, method, source, dest, and status. Those all feel like things that won't insanely blow up your cardinality. Historically, we used to be very cautious about recommending container ID in this case, because containers are ephemeral. They're coming up and they're coming down pretty much continuously, and the cardinality on that will just increase. But with a lot of the changes that we've made to TSM, our TSI, which is our disk-based index, those problems have mostly gone away. And so we can easily handle cardinality in the billions. And then for the fields, I would recommend, request ID as a field, duration, bytes TX, and bytes RX. Cool. That is actually all that I have, and I'm happy to kind of open it up to questions. And yeah, thank you. Sure.
Well, I can pick on you, John. I know you have this problem. Anything that, any questions that you want to present to Michael about this? Is this starting to make sense why your dashboards were having some problems?
So anything that's high cardinality, we should make it a field instead of a tag?
Not anything. You just want to be mindful of it. Or you want to be mindful of how many series are being retrieved off of disk when you create a query.
So what creates a series?
So a series is the unique combination of measurement, tag set, and field. So if we go back here, So a series is defined as, say if I had 1,000 different hosts, right? If we just changed it from host server A to host server 1 through 1,000, and I just had these values, that would induce a 2,000 series, because for each one of these fields, I get a series.
So, but if fields is part of the series, then how come fields can have high cardinality?
Fields, the value of the field is not, the name of the field is.
Okay.
Yeah. You can really think of the field name as like another tag.
Okay. Thank you.
Any other questions? Yep.
This is a little off topic from this part, but I was trying to understand the difference between TSI and TSM and
Yeah,
which one
really
I
great
want to
question.
use and how I move from one to the other.
Great question.
I think I'm TSM right now.
Yeah. Do you know what version of Influx you're using?
1.7. Whatever the latest
So you
is.
should be using TSI as well. So a while back, we used to have an in-memory index for basically looking up where time series data was on disk, so which series existed in which files. And that wasn't scaling when people wanted to do like a containerized environment where you have these ephemeral kind of container IDs coming up and down. So we started to think about what it would look like to have a disk-based index for time series, and that's what TSI is. So historically, we had it optional where you could specify that I'd like to have TSI enabled, or enabled or disabled. But pretty early on, we decided that once 1.7 came out, it was finalized, and we put it in for every single release. So if you're using 1.7, you have TSI enabled.
Are there any caveats around, well, if you have a certain type of workload, you should stay with TSM? So I have like insane ingest rates, but not significantly high query rates. Would that make any difference?
At the moment, it's not. You can't disable it, so it's kind of just comes out of the box. You can do some tuning on it, but we haven't seen any major impact to the ingest performance from it.
And I would assume there's documented somewhere, if you're TSM, here's how you convert to TSI with minimal downtime.
Yep. Yeah. And if you're in 1.7, I would assume that you already are using TSI.
Oh, how can I tell?
If you go in your config and there's not an option for it, you're using it.
Okay. I started with an earlier version and then upgraded, so maybe I'll take a look. Thanks.
Yeah, we probably did a silent kind of upgrade behind the scenes at some point.
Okay.
Any other questions? Oh, good.
Hey, so what I was thinking was, we do have a few fields, meaning a few fields in our data whose cardinality is pretty high. But we don't really want to search on those fields, but we make them tags because I think the Influx query language doesn't allow you, you to group by the tags.
Yep.
Meaning group by the fields. So just because we want to group by those points, we end up making them as tags.
Yep.
And that makes the query
Slow.
pretty slow. Yeah.
Totally. Yeah, so that's actually one of the really great things about Flux is we've added the ability to do group by tags, or by fields. So that was one of the major limitations that we had in InfluxQL, and it has been removed with Flux.
And is that only part of Influx 2.0, or is it even
It's available in 1.7 as well.
Awesome. Thanks.
Yeah, you're welcome.
If they're not moving over to Flux, is there anything they can do to minimize that or avoid that besides just keeping them as field values?
The short answer is mostly not, and I would recommend using Flux. That being said, if you wanted to do a larger reshift of your schema, there's usually some way you can come up with for fixing that problem. Some things I've seen people do is as data comes along, they forward it to capacitor and have capacitor do the modifications just for the pieces of data that they want, so not all of it, so that they can get a similar kind of effect without having to create a very large amount of cardinality for a subset of the data. Yeah.
So if you are ingesting data through Prometheus, which is using OpenMetrics, what would be the translation for fields and tags?
Yeah, the translation is you have the metric name is measurement, and then the labels are tags. And then the value that kind of comes out to it depends on the type of metric. So if it's a counter, the field will be called counter. If it's a gauge, it'll be called gauge. If it's a histogram, it'll be called, our summary, it'll be called the appropriate things for that.
Any other questions from the audience? Okay, I'm going to pick on some people. David, you must have done some weird stuff. What best practices can you share with the audience?
Bold.
As you're thinking about that, maybe, Michael, you can share some other examples with everybody of some stuff that you've seen where people have helped themselves get out of a jam, right?
Yeah. So another thing I think I've seen people do pretty regularly, because we used to say, like, put your cardinality, people used to always come up and say, can I have like 1,000 fields, right? And for a while, the database will kind of let you do that, but it can get really difficult when you want to issue like a generic query, like a select star, and you have 1,000 fields, and they all start pulling out at the same time. It really grinds things to a halt. And so I would recommend against doing that as well. Yeah. So you want to put all of your cardinality into tags. You want to make sure that the cardinality is not used in fields, or field names specifically. So cardinality, we've built the system around cardinality existing in the measurement and tag space and not so much in the field space. Fields are really, like the number of fields that exist are really supposed to be just kind of like a simple logical grouping. So I've seen people who like have a field per customer, or sorry, a measurement per customer with every single measurement having the exact same set of fields. And they thought, I can just access everything super easily, but we didn't design the system for the field set to be that large. While it will allow you to do that, you will start to hit kind of very odd, non-intended performance issues.
So I think it's worth just defining cardinality in the InfluxDB sense, because it means a little bit something different in relational database terms.
Yeah, that's a really great question. I totally took that out of that, so my apologies. So when we refer to cardinality, we're referring to the number of unique measurement and tag set combinations, right? So if I have 10 hosts and each of those 10 hosts is collecting 10 different metrics, I will have 100 series, or a cardinality of 100. And so when we talk about cardinality, we think of all of the ways that that can kind of manifest, so like all the different combinations. And so a common mistake is to think that the total cardinality that you have is the number of the cardinality of one of your tags times the cardinality of all of your other tags. So if I have, host and, container, right? The product of those things, like if I have 10 hosts and 10 containers, I would imagine that I would have 100 series. But that's not necessarily the case, because usually a single host runs on a single container, and so they're not split apart. So you have dependencies between tags. In that example, there's really only 10 series, right? So it's not necessarily a multiplicative thing where the cardinality of my instance is the product of the cardinalities of my tags. There's complex dimension or interrelationships between the tags themselves.
So if I wanted to know the cardinality of my database, I've seen something referred to as a series count, or num series, I think is the name of the field. Is that the same thing? That's what I'm looking at?
Yep, yeah. And the thing that might not be included in there, so we used to have a couple different definitions of series. We used to just refer to series as the measurement and tag set, but pretty recently we've switched that definition to also include the field key. So that value might just refer to the measurement and tag set. So say if you have 1,000 fields that are associated with it and 1,000 series, you would only see 1,000. You wouldn't see the 1 million that was a result of that.
Okay, so that might explain something. So I hit a limit of 1 million on my series count, and it got unhappy. So I raised it. But I was trying to figure out, how do I know that I went past 1 million? Because when I look at the series count, I only have 600,000 or something.
Yeah, it's probably related to something
Okay,
like that.
so can I get that number?
There should be something, I believe, a command called show cardinality that will show
I'll check
that.
it out. Thanks.
Yeah.
I think that's been there for a while.
Yep.
Any other questions? Oh, here we go.
Do you have any advice for evolving schemas over time? Like if the types on my fields are going to change and how that affects queries or the database?
Yeah, that's a really great question. So the question, more or less, is how do you think about changing your schema over time? And historically, if you ever wrote a value, that was the type of that value until the shard rolled over. So you could never change it beyond a shard boundary. And so you would have to make schema decisions at very intentional kind of periods of time. So I would recommend taking an explicit decision. So I'd probably just start out and write your data, and just whatever lands. And then once you get to a place where you're starting to experience a little bit of issues, I would recommend making a very intentional decision to make modifications to your schema, possibly splitting into 2 separate databases and doing a dual write for some period of time and then cutting things over. The database at the moment is not particularly forgiving if you want to make very large-scale schema modifications after the fact. And most of this comes from us optimizing around the now kind of use case, right, where you can evolve your schema relatively easy as it changes now, and not so much for things in the past. Yeah.
And
Hi. Do you have best practices as to how to choose a measurement? So, for instance, if you have, in case of IoT, if you have a thing with 5 temperature sensors? Should you have one temperature measurement and sensors as tags, or should you have one measurement per sensor?
Yeah. So it comes back to that initial question that I asked is how do you want to be querying your data, right? What types of dashboards do you want to use, and how do you want to select it? So I personally would recommend that you pick the higher level grouping, so where you would have, say, temperature and humidity or things like that, all as separate measurements, and then just logical kind of values associated with each of those. So maybe it's like, temperature in Celsius or temperature Fahrenheit, something like that. And then as tags on each of those things, I would put like device ID or something like that, rather than having separate devices as measurements. With Flux, it's becoming a little bit more arbitrary which way you choose it. And as for like the indexing, they should be roughly the same. Internally, we also turn the measurement name into another tag. But I would probably still recommend doing the grouping by like metric type, and then having a tag that is associated with the value, like the device thing type.
Thank you.
Yeah.
So I think it's worth spending a little more time on this planning kind of a phase, because we brag about being schemaless, but you can get yourself into quite a jam.
Definitely, yeah. The strategy I usually recommend is get up and running, try to get something going. Once you have that, start to make very intentional decisions about your schema. Start thinking about which dashboards you have, and then make that schema modification. That's mostly been what I've found the easiest way to kind of get going, because you can get your proof of concept with not having to think about the schema so much. And once you need to go into production, you need this thing to be reliable, then you want to start making sure that you make those decisions and being very intentional about which dashboards and which queries you need to be up on a dashboard and refreshing every 5 seconds versus ones that'll run in a monthly report or something like that. But yeah, I totally agree.
Dylan, Gianluca, I'll let you guys think about that.
So I've encountered an error related to a property maximum values per tag. So in the example that is shown, so you had the server's status being recorded, and say we are recording that status for maybe, we are retaining the data for maybe over a year. So you would end up saving more number of records per tags, right? So what if there is a use case we wanted to retain the data for a long period of time, but you would start encountering this error because the status 200 container ID app could be remain unchanged for a period of time, and you start hitting this number. So do you recommend changing those values, or is it usually not recommended to do anything about it?
So let me make sure that I understand correctly. Is you have data that you want to keep around for a very long period of time, and it's more or less this is just going to keep increasing ad infinitum, right? It'll just keep growing. What should I do in that case? One, it depends on the hardware that you have, right? If you have enough hardware, it won't be a problem. Ish. Eventually you'll run out. One thing that we've been working on in 2.0 that was not a feature of 1.0 is this idea of being able to put series into cold storage. So you can remove the data from being resident in the cluster, but you still have it around. And so we'll have this concept of like hot data that is like actively being used, and then cold data that you maybe put in S3 that can be reloaded back into the cluster when you need to. That's still coming along the ways, and it should be out, it's on the product roadmap, but is not something that will probably make it into the 1.x line. For that use case, I would maybe recommend trying to think about, do you need the full resolution of the data, or can you deal with like maybe a downsampled version of that? That's probably what I would start to try to think of.
And then I had another question regarding having a backup of the data. So how would you recommend designing a backup for the existing InfluxData?
So there's 2 ways that you can do backups. You can snapshot the machine, which is actually what we do in our cloud product. On top of that, there's a backup command that you can run against the database, and it will create a backup that you can put in a particular directory somewhere. Depends on which one that you really want to do. Machine snapshots work pretty well for us, and that's kind of what we do internally, but the backup command is something that people use as well.
Thank you.
when I saw that example with the path inside, there is something to mention that if you think about a REST API where you have /users / the ID, and you use the path, that path has a tags, it doesn't really get to a cardinality so high that can be crazy or can become a problem, but you don't really get the result that you are hoping for when you do grouping, because you can really group for give me the get single user request, or at least you can do it, but you need to do regex and to do something really not easy to do. So something we did was to translate the path to the name of the root and use the path as a field. So this can be useful as well.
Definitely, yeah. Yeah, so some additions, as Gianluca was saying, is you can start augmenting these values. So maybe you want to be able to look at all things that were 400s or 300s. You want to group by things that are 300s. You can start modifying your schema. Hopefully what we'll be able to start doing in Flux is to just issue queries that handle that stuff for us. So we just write the raw data, and then we can have Flux kind of do the logical groupings that we want to, whether or not it's a 400 or 300, 300s redirects, or anything like that. Yeah, definitely.
Anybody else want to share some best practices or things that you should not do? I know, I mean, we keep saying this in all our trainings, but it is, I think, the best practice to think about what you're trying to achieve in a dashboard or in your queries. But it's hard, Michael, because it's so easy to just throw stuff in.
That's how we get you hooked.
Yeah.
How about a question about caching? So I pour data in real fast, in a lot of it. And I can always replay it, so I don't much care if something crashes and I lose, the last n gigabytes. But I gotta go as fast as I possibly can on ingestion. So there's a parameter, I can't remember, it's kind of a long name, but it's something about memory caching, something or other in gigabytes. And I think the default is like half a gigabyte. And I set it to various things, including 0, which means just go until you crash the machine because you run out of memory. So that was no good, don't do that. But I ended up with like 40 gigabytes or something. What are the trade-offs on that guy? Can I just keep buying virtual machines with more memory and cranking that up to go faster? Or what are
I'm sure you'll hit some kind of limit, but that should work for a while.
Mm-hmm.
It's been a really long time since I've done any kind of tuning on the specific values for TSI or TSM, and I probably couldn't speak to that in as much detail as I'd like to without being able to look at the code.
Okay, was that guy different on a TSI versus TSM?
Should be the same.
It should be the same, so it's just what I'm caching in memory now.
Yeah.
Okay, all right.
So in the afternoon, we do have 2 other sessions that are going to be going in depth into optimizing the architecture. So Sam and Craig, who are 2 SEs, will be talking about that. We made sure we moved those sessions so they weren't at the same time, so you could go to both of those sessions. In any event, if you can't make it, they are recorded, but I do think it's worthwhile going to those sessions to hear a little bit about those best practices as well. Okay. Well, thank you very much, everybody.